Okay, so this is how to solve problem 19 on page 74 in the chapter 3 homework of vectors. So the first thing we need to do is draw a diagram. So we know that the man has pushed the mop across the floor, again causing two displacements. And the displacements make angles with the positive x-axis. So first thing we need to do is understand what the positive x-axis is. So when you draw a Cartesian plane or a coordinate grid, obviously, okay, so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And as the x-axis gets larger or more positive, we would want this area going to the right to be the positive x-axis as the values get larger as they move along. So imagine it like this. It goes all the way up, and this line would represent the positive x-axis. Okay, the next thing we know is that the first leg has a magnitude of 150 cm and makes an angle of 120 degrees with this line. So an angle of 120 degrees would be greater than 90. So 120, that would be an obtuse angle. And 150 cm, 150 cm. Okay. And the next thing we know is that the resultant displacement has a magnitude of 140 cm and is directed at an angle of 35 degrees to the positive x-axis. So from the same positive x-axis, the resultant displacement, so remember that we have a missing leg that should be connecting this leg and that leg. So the resultant displacement has a 35-degree angle. So it should be somewhat like this, and this particular angle would be 35. And I feel like this diagram is a little bit confusing now, so let me just erase this 120, but just keep it at the back of your head that this whole thing is 120. And let's see, and this would be 140 cm. So from here, what other information can we conclude? So because this is 35 degrees and this whole thing is 120 degrees, this segment right here, this segment between this leg and that leg, should be 120 degrees minus 35 degrees, which is 85 degrees. So we know that this is 85 degrees. So we're finding out more and more about the triangle that we want to know about. And what we're looking for, the first thing we need to know is the magnitude of the second leg. So what is the distance? So we're looking for this. So one of the formulas that I learned from my trig class last year was the law of cosines, which is basically an extension of the Pythagorean theorem for non-right triangles. So it goes a squared equals b squared plus c squared minus 2bc cosine of a. So what do the variables mean? So a squared is obviously the unknown side, so this side. And b squared and c squared, or b and c, are basically the two other legs. And cosine of a, so the angle a would be the angle opposite the unknown side. So because we have two sides and an included angle that is opposite the unknown side, we can use this formula to solve for this unknown length. So a squared, so now I'm just going to substitute the values. We're going to make 150 cm b, so 150 squared plus, and 140 would be c, 140 squared minus 2, 150 times 140 cosine of 85. Okay, and you can do this manually, or you can solve it by segment in your calculator. This would be 150 squared plus 140 squared. Wait, let me just look at that. Oh, plus 140 squared minus 2. Okay. Minus 2 times 150 times 140 cosine of 85. And immediately we get this huge number. A squared equals 3 8439.4588. So the square root of this should be, our a value. So let's go back to the calculator and take the square root of the answer. So a would equal 196.06 cm. So if we can move this along, we know that this side 196.06 cm. Okay, the next thing we need to do is find the direction of this. So from this diagram itself, we can conclude that because this is not a perfectly straight horizontal line, it does have an angle with the x-axis. So if we draw a straight line here, actually let me just draw this again. So picture it like this, and this is the leg we want. This is the chosen leg. And imagine that it has an angle with a positive x-axis. So we want to find out this little sliver of an angle over here. And from this we can tell that it is some angle south of east, because this is the east direction and it is south. So we know south of east. But how are we going to find this angle? So some conclusions we can immediately make are this triangle is a right triangle because of this side. So if we have a perfectly straight horizontal line and we are looking for a perfectly straight vertical line, these two lines are perpendicular and will cause a 90-degree angle to be formed. And what else do we know about this? The side we solve for is the hypotenuse. So this area would be 196.06. And is that all we know? Yep. So we can look back at the original diagram to find out more information about this. So from this original diagram, we can separate this, like this whole sketch, into different triangles. So this first triangle, I see a triangle over here which has 150 cm. This is a right angle, and we don't know what this angle is. We also don't know what this angle is. However, from looking at these two angles, so this is 85 plus 35, but remember that this is a perfectly straight line. This positive x-axis is a perfectly straight line, and this whole ray takes up 120 degrees. And what is the supplement of 120 degrees? That is 60 degrees. So we know that this is 60 degrees because this one, same angle as this one. And we know that all triangles have to have 180 degrees. So this is 90, this is 60, and this must be 30. So from there we can solve for this height. So let's see, what is a what would work? Sine of, I'm looking at the opposite of 60. Sine of 60 equals x over 150. So 150 sine of 60 would equal x. So put that in a calculator. 150 sine of 60. So we know that x is this value right there, 129.9. And so we know this height. And the next thing we need to do is find this height. Because if you look at it from a triangular perspective, so this height minus this height would equal this height. Imagine this is a perfectly straight line and the sides are equal. So this is the total length of the side and this is a segment. And this is the remaining segment that needed to be completed for this side to equal this side. So this minus this equals this. Going back to the original sketch, we can do the same for this triangle. So just draw like that. And make this a right angle, make this 35 degrees. So 180 minus 90, that is 90. 90 minus 35, that would be 55. So we know the angles of this triangle. That's 35, 55, 90. And what else do we know? The hypotenuse is 140 cm. So we are looking for this area because this would be the height. And what would work? So this is opposite and then hypotenuse. So sine of 35 equals x over 140. So 140 sine 35 equals x. So just put that in your calculator. 40 sine 35. So that would be 80. So this side would be 80.3 cm. So now that we have this height, we can go back to this diagram. So from the first height, so this is 129, and 180. So we can subtract 129.9 minus 80.3 would give us the height of this. So minus 80.3. So that would be 49.6. So 49.6. And do we have enough information to solve for this? So let's see. Let's draw this as a completely separate triangle. So we know that this is a right angle. This is 49.6 cm. This is 196.06. And let's see. Okay, let's call this theta. So this side would be the opposite of theta, and this side would be the hypotenuse. So sine of theta equals 49.6 over 96.06. So the inverse sine of 49.6 over 196, the inverse sine of 49.6 over 196.06 would equal theta. So put that in your calculator. Inverse sine, divided by 196.06 should be equal to 14.65. So theta is 14.65. So now that we have this, if we look at it from the grand scheme of things, we already have the magnitude of this line because we have the distance. So magnitude equals 196.06 cm, and we have the degree between this and the positive x-axis, which would be theta. Theta equals 14.65. So 14.65, 196.06 cm. So let's put this in a conclusive answer. So leg 2 magnitude is 196.06 cm with an angle 14.65 degrees south of east. Done.